In this video, we are going to be talking about graphing skills. So this is help that's going to set you up for success when it comes to graphing in class. By the end of this, you should be able to explain the difference between a line graph, bar graph, and pie chart. You should be able to use each type of graph. You should be able to explain the importance of tails and dry mix. Line graphs. These are used to show data that is continuous. Points are plotted using the X and Y axis. You connect your points, and it shows relationships between IV and DV. So IV, this is the independent variable. DV, this is the dependent variable. Remember back from the scientific method. Independent variable, this is what you are changing. The dependent variable, this is what is being changed due to what you have changed. Typically, the independent variable is plotted on the x-axis, and it's usually time. With line graphs, typically, we deal a lot with time. So this is what a line graph looks like. If you were not picturing this as a line graph, maybe you were picturing a scatter plot. Scatter plots, they are similar to line graphs, but they don't show change over time, and they're just a bunch of dots not connected. So an example of a line graph for this picture in this case, it's earnings per day. You get to see how much money somebody makes each day of the week. Now let's talk about bar graphs. For bar graphs, data is not continuous. Typically the bars don't touch. It allows us to compare descriptive data like amounts or percentages or categories, and there is no order to these categories on the x-axis. It doesn't matter if you put the first question you asked last or the last question you asked first. The order on the x-axis does not matter. So here's an example of a bar graph. This is the birthdays of students by month. So you did not need to put it January through December like the months of the year, but in this case they did. You can see that there is space between each of the bars. It just shows how many kids have birthdays in that month, and you're just comparing the fact more of the students have birthdays in June than the rest of the months out of the year. It's just used for comparison. And pie charts. Pie charts, the data is not continuous. Usually it presents data as parts of a whole or as percentages, like categories that add up to 100%. So in this case, the picture here is favorite types of movies. They went through and asked a bunch of people, turned it into a percentage. So 4 people, which is 20, ended up in this case being 20% of 100, liked comedy. 4 people, 20% of whatever they had, liked sci-fi. So you could go and survey 60 people about their favorite type of music, their favorite food, whatever, and end up turning that into a percentage and creating a pie chart out of it. It's just to show parts of a whole. So now let's go through these and see if we can figure out which type of graph you would use for these. So the first one, this is the example, the amount of each color of M&Ms in a bag. You would use pie chart, you would use bar graph for this, because you're going to open a bag, sort through the M&Ms, put the same color in each pile, count them, and then write like green had 3, red had 2, so on and so forth. So let's try the first one. Heating a pan of water over a time period. So remember what I said with line graphs. Usually deal with time. You're looking at continuous data because you're trying to look at the temperature of a pan of water as you're heating it over time. So this would be line graph. What about shows number of students earning A's, B's, and C's? Well, we're going to look at the number of students who earn A's, look at the number of students who earn B's, and look at the number of students who earn C's. So in this case, we would use a bar graph. What about measuring the percentage of each gas in the air? Hint, hint, keyword percentage. So in this case, we're going to use a pie chart because it's a part of a whole. We are looking at small percentages or large percentages of gases in the air that equal up to 100. What about shows the percentage of allowance spent on different things? Again, keyword percentage, so it's going to be pi. What about shows height change over a period of 15 years? Well, change over, so that means it's continuous data. 15 years, that's a time period. So we've got time, continuous data, must be a line graph.